I'm sorry. So let me just go back here. So I'm working on number 5. So I have the acid here. So actually the water liquid from the potassium. So we're going to find potassium. It does have the reaction with the water liquid to form hydroxide H2 gas. That means it does have reaction. And actually why we need to think about the water or the acid, because they all have the hydrogen. So which one is going to kick? The K is going to kick the hydrogen, because hydrogen shows up in all the water and the acid. Okay, so that's why we circle the hydrogen. All right, so here first of all I'm going to highlight the water liquid. So we know that it's water liquid. Now because we can actually copy this, okay, we can copy this, but we change the metal to be K. Okay, we can actually copy this, but we change the K, and we are not dealing with the gas, so then don't write the gas. So we just change that metal to be K, and then the water liquid, and then oxide and hydrogen gas. So we're gonna copy this sentence because it had reaction. So we're gonna write, because we have the reaction, okay, we does have reaction. Okay, so we're gonna write K, all right, so we follow that, K plus, right, plus H2O liquid, I just copy, right? I just copy to form hydroxide plus H2 gas. I just copy, okay? To form, now hydroxide here, I'm gonna use the green color, right? I'm gonna use the green color. Hydroxide, and then H2 gas. And then I'm going to highlight this now. Okay, so how do I know it's hydroxide? Because the reaction told me that when the K in this section we add with water liquid, they form hydroxide. It's right here. They tell you that. And then H2 gas, okay? It's not something I make it up. It's given to you, all right? So which is the same situation as like here, okay? How do I know that if from this is you can read it from here, all right? So then now, because of the reaction take place, so what did I write? Then we can say, oh, that thing, that metal can replace hydrogen. So here, I'm going to underline the K and H. Okay? So K and H, we're going to see if the K replace the H. And it will, because it told me that you have reaction. So in this case, I'm going to write K can replace hydrogen. Okay, you can actually get this all from here, all right? So then now, because we have reaction, we're gonna change the identity, all right? So first, K gotta change to K plus. Okay, how do I know change to K plus? Well, it's right here. It must be either K or K plus. K has no other change, no other charge. You see that they all given here. So K gonna change to K plus, okay, because reaction take place. Now H2O, we first want to separate them first, okay? We're gonna separate them first. What are we gonna separate it? One of them must be OH minus, because on here you tell me that they form OH minus, so it must be form OH minus. I'm going to separate them. I separate them. I did not change anything. Okay, I just separate them. Now, if H2O form OH minus, what will be the other positive? The other positive must be H plus, right? Must be H plus, because these two will form water, right? Plus or minus, zero charge. Okay, H2O. Okay, so it must be form OH minus as the princess or whatever, then this one will be the prince, H plus, okay, H plus. Now OH minus stay there, all right, here's the princess stay there, but H plus gonna change the identity, so the H plus gonna change that to H2, okay. Then now we're gonna kick, right, K plus, kick the H to become H2 to the end of the bathroom. All right, so I'm going to kick him out to H2 to become H2, and H2 is a gas, okay? H2 is a diatomic, so it's a gas, right? And then now I'm going to have the K plus, right, play with the OH minus. So K plus, and then OH minus, and then they dance in the black ballroom, all right, to form back KOH. And then when I check the solubility, it's actually aqueous. All right. So, and then at the end, I'm going to balance the equation. The balance equation will be 2, 2, 2, 1. Okay, and balance equation will be 2, 2, 2, 1. Okay. Now it looks like I write like separated, but actually you see my answer key. They should be written a little closer, but you can tell the idea. Okay. So I'm gonna make sure that I highlight this OH minus. How do I know OH minus? Because they form reaction with the OH minus. Okay. Right, now I'm gonna do number 6. Okay. Now zinc and water liquid. So we're gonna find out if zinc has reaction with water liquid. So zinc is right here. Water liquid. I did not find water liquid. I only find water gas and acid. If you don't find anything, actually means no reaction. There's no reaction here. So I'm gonna underline the zinc. Right, underline the H. Right, so only take the happy out. Right, so there's no reaction, right? So there's no reaction because I do not find anything here. So I'm gonna write zinc plus H2O liquid. It's actually no reaction. Now this one, you don't find it from here. You will not find that. You did not find zinc has no reaction with water. But if you did not find it here, that means no reaction. If there's a reaction, it will tell you reaction. If you don't find it, that means no reaction. Okay? So zinc plus H2O liquid will be no reaction. Okay, I'm gonna highlight the liquid. Okay, so no reaction. Okay, if it's a no reaction, I'm gonna draw like this, no reaction, and then also no reaction. I'm gonna write no reaction. So then, because there's no reaction here, right? So that means zinc can't replace hydrogen. Zinc cannot replace hydrogen. Anything no reaction, you cannot do a replacement, right? So all the explanation are here. They are here. Okay. Now I'm gonna do number 7 too, right? So number 7, you recognize that H2CO3 is actually a gas. H2CO3 aqueous is actually an acid. Okay, H2CO3 is an acid. So this kind of acid. Okay, so I'm gonna look it up nickel to see if the reaction with the acid. So nickel, it does have the reaction with acid. It will form salt and H2. So what does that mean by salt? It will just form back the whatever the negative charge. The negative charge is part of the salt, and then the H2 gas. So it does have reaction. All right. So I'm gonna underline the Ni, and then I'm gonna underline the H. Okay, because anything with the acid or water, they're gonna play with hydrogen. That's why I circle the hydrogen here, because they involve in water and the acid. Okay, so only take the happy out. Only take the happy out. Right, it worked. So how do I know that it will happen? All right, because you gotta write the equation here. Okay, because I'm gonna just rewrite, instead of the word metal, I'm gonna just replace with the H. Replace with the Ni, and then plus the acid name. Okay, to form salt and H2 gas. All right, so I'm gonna write on here. So Ni, okay, plus acid. I just copy here, but instead of the metal, I change that to nickel. So nickel and acid, they will form salt plus H2 gas. Okay, I just copy from there. So what does that mean? If it works, the reaction takes place, then nickel can replace hydrogen. Again, why is the hydrogen? Hydrogen is in part of the acid. Okay, so it worked. So if it worked, that means we're going to form this back. Okay, so first of all, we're going to change the identity. So the Ni, we're going to change the identity to Ni2+. Okay, we're going to change the identity to Ni2+. And here, first of all, you're going to separate them.